Hello friends, today I'm going to present to you one of the script which I have recently made. So basically I was I was working for the post-tension eye girders and pre-tension eye girders. So this is the script which I have generated which will automatically um, model the whole cross section in the geometry, uh, the bearing orientation as well as load combination and do the analysis for all those things. So basically, this is supported by .json file. The cross sections are written in .json file. So before starting, I'll just like to mention you that the whole script, and then I'll explain you the each part. So this is the input and cross sectional details. So whatever is the cross sectional, the width of the top flange, bottom flange, and all those aspects is written here. Likewise, so there are mainly two sections as you know in PSCI guiders. One is the end section, other is the mid section. So likewise, I have defined here the end section, and this is the middle section, sorry, and this is the end section. And this is the main input, so in which the main input of the main parameters like span, width, and everything is to be input in this format. So here I have prepared this script using the station and placement concept of Sofistik, and here you can insert your station points 0, 0.5, likewise till 50, and let's say we have three supports as of now, and I have a special input of web thickness over here because when our section will move from end section to wearing section, we need to input some data about the variation. So that is why we need this thing separately. And this is end section web thickness and mid section web thickness. These inputs are required because to loop it again here, so that the values remain constant. Means the value remains compatible with the during the interpolation. So after inputting all these things, so here if you see that I have read the input file, and likewise I have selected the sheets, and these are the station values which are later into this road axis. So it will generate the road axis automatically, and these are the placements which will be used further. This is axis 1, 2, 3. Basically, this is made for three girder system, and this can be x1, x2, 5, or multiple girder systems using the same script. But we need to either copy this, make it a copy and do it like that, or we can do that using Python, Grasshopper Python component. So this will generate an axis, and this axis has cross sections and placements. Based on this, it will generate a structural line, and this line will be then input for the Sophie mesh C, that is the geometric definition. So similarly for tendons, we have used one more Excel uh, wherein we input all the tendon points and station, and that is read in the script, and likewise the tendon is also modeled. So this is for the supports condition, and for the temporary support we need for construction stage analysis also. So that is support axis 1, 2, 3. So here starts the loading part. The self weight is automatically added, and the crash barrier and deck wet load is added. So structural area deck will have two loads. One is the wet load of the concrete, another is the breaking load. This is the live load part. So first comes 70R. As you can see that here there is a transverse offset. So for example, if you wish to run your vehicle not exactly at the center, say 2 lanes or multiple lanes, then you can use this parameter, and if you just With this slider, you can change mm, the loading pattern. So this is like class A. This is class A plus 70R. This is live load. We'll run the live load for the analysis. This is the thermal load. The thermal load is as per IARC. That is the differential thermal method. So all these values are from IRC 6. This is the live load combination, means amongst all the live load we need to find which one is the governing one. So based on that, we'll then use that in another combinations. Now, so these are ULS combination, SLS combination, and quasi-permanent combination. So here you have to put factor for dead load, breaking load, thermal load, and live load, like this for SLS and quasi factor. So after doing all these things, this script will generate all the TEDdy files, and after generating the TEDdy files, if we run the whole analysis, we can see the results. This is self-hit, crash barrier, deck slab, wet concrete, braking. These are the live loads, temperature rise, temperature fall, and these are the construction stage analysis, deck wet load, deck hardening, composite action, and creep and shrinkage. So these are the ULS parameters, maximum MY, and these are the SLS and quasi. So basically this script generates, so you can have as many stations as you want, means there you can have multiple span, like here now right now it is like 2-span continuous system, as you can see here, but you can have as many as you like. And one more thing is I have joined this with the Tekla. So if you open your Tekla, and I'll show you where it happens. So here is the thing. It will, whatever geometry is generated, it will then export it to Tekla. So yeah, you can get a fair idea of how the cross section is modeled in Tekla, and you can have real time experience of this. So talking about advantages, the advantage is that it is very fast, very quick. We just need to input properly the input data and the tendon data. Automatically all the loading combinations, everything is created in this. So it can be used mainly for the tender purposes or rough estimation. One can also use for detailed design if our bridge is a standard bridge, or if it doesn't have any curvature or that sort of problem. Disadvantage, or you can say the limits of this, is that this script which I have generated, it doesn't work for multi-axis, like more than it doesn't work for the more than 3 axis, 3 girder system. So for multi-girder system, either we need to create one more script or we need to edit this thing. Apart from that, you can, if you see at the tendon, and if you just remove, here you can play with the slip and friction parameters, and then you can either if you make it 0, then it will be a pre-tension or post-tension system. And I just want to show you one more script so which is useful for both ways. You can just go into this input, and let's say if we remove, mm, you can see that it is converted to single span. So likewise, you can change the parameters and you can decide whether you want single span, multi-span bridges. Thank you.